In this video we're going to talk about carboxylic acids, and carboxylic acids have a functional group that is kind of a blended functional group, as you can see from the diagram, and I'll talk about that in a second. But first of all, just a bit of background or history of carboxylic acids. So this is an ant. Ants sting things, and that chemical that causes the stinging is actually a carboxylic acid. It's known as formic acid. That's after the Greek formica for ant, and there's the structure of formic acid. So you can see one carbon. So actually the IUPAC name for that is methanoic acid. This is one you've probably seen. Well, certainly you've seen this iconic bottle holding vinegar. Well, vinegar is actually comprised of a certain percentage of acetic acid, a carboxylic acid. And so acetic acid has two carbons, 1, 2, and so its IUPAC name is actually ethanoic acid. And finally, wart zap. Well, that sounds really pleasant. Actually, this chemical is used as a wart remover, and it is a carboxylic acid known as trichloroacetic acid, TCA. And there you can see the 3 chlorines bonded to a carbon, 2-carbon compound, but there's our carboxyl group. So carboxylic acid is very widespread with, as I said, this blended functional group. So let's just have a look at the carboxyl group. So the carboxyl group is a carbonyl group with a hydroxyl group. So if we look at this particular compound, there's my carbonyl group, and here's my attached carboxyl group. So that is the carboxyl group, that entire part of the structure. And like an aldehyde, for example, that contains just the carbonyl group, a carboxyl group has to be a terminal group. And the nomenclature is very straightforward. We take the ending E off the ane of the carbon chain, and we add this suffix oic acid. So carboxylic acids, amongst the easiest to both recognize and name. So let's look at this first molecule. I start numbering from the carbon of the carboxyl group. So this is carbon 1, 2, 3, 4, 5. So it doesn't really get much easier. Pentanoic acid. Pentane, take off the E, add an oic acid. Pentanoic acid. Well, here I have a benzene, but there's my carboxyl group. So this would be known as benzoic acid. Okay, so there's a couple of carboxylic acids. Let's have a look at a couple more. Here's my functional group, so I'm going to start numbering 1, 2, 3, 4. But I do have this methyl branch here, so that becomes 2-methyl butanoic acid. Okay, 2-methyl propanoic acid. Well, propanoic acid, propane, 1, 2, 3. A 2-methyl, so there's my 2-methyl, and it's a carboxylic acid. So let's finish off this functional group. COH, double bond O. And then I would satisfy the carbon bonding with hydrogens, and there's my 2-methyl propanoic acid. 1,6-hexane dioic acid. So hopefully you recognize what that di in front of the oic acid means. It means it's a carboxylic acid with 2 carboxyl groups, because they have to be terminal. They're on carbons 1 and 6 of a hexane. And even though the numbering is redundant, you always see dioic acids numbered. So there's one terminal carboxyl group. Here's another terminal carboxyl group, and then I would simply add the hydrogen. So there's 1,6-hexane dioic acid. This particular molecule actually is a precursor to some polymers we're going to talk about later. So 1,6-hexane dioic acid. Carboxylic acid is a polarity. Well, not surprising, the carboxyl group is a polar group. The delta N for that C double bond O is 0.8, and then we have a delta N of 1.2 for the OH group, of the OH component of that carboxyl group. So we always have a bond dipole, and therefore a strong molecular dipole. This is quite a polar functional group. And so that dipole is stronger than most alcohols of similar molecular mass because there are two polar components that can form intermolecular force of attraction with neighboring molecules. If you look at our propan-2-ol, molecular mass of about 60, an boiling point of 82 degrees Celsius, here's equal molecular mass carboxylic acid, ethanoic acid. And the whole point being here, with this polar group here that's going to be delta negative, that is where it can form an intermolecular force with neighboring molecule. This is also a delta negative component around this oxygen, and so it can form intermolecular forces off the OH group as well. So with two groups capable of forming intermolecular force of attraction or attraction between molecules, it has a higher boiling point. And so that's the carboxylic acids. Pretty straightforward. The functional group is easily recognizable. The functional group is terminal, so that's going to give you some guidance on numbering. And because of the two elements that are polar in the functional group, carboxylic acids have quite a high boiling point relative to similar molecular mass molecules. And that concludes this video.